authentication. We'll discuss authentication, encryption, and access control. Then I'll cover some of the Azure-native tools like Azure Key Vault and APIM. Then I'll provide some of the real-world examples and the mitigation strategies using Threat Modeler. How many of you are familiar with Threat Modeler? Have you used it in your applications? Okay, just one person, a few people. So I'll walk you through how Threat Modeler can be used, especially early in the SDLC. Also, I have over 5 years of experience with Azure. These examples are mostly for Azure, but the principles can be applied also to other cloud environments. How many are using Azure, AWS, AWS? Other private clouds? So you have, I know you have a private cloud as well. All right. The next part, we will explore common cloud security threats. The first one, the authentication abuse, is one of the most common root causes for data breaches. And this is due to the weak or used credentials. It's actually different from authentication bypass, as the users are authorized, but there are flaws in the authentication system that are exploited by attackers. Next, the malicious insiders, whether intentional or accidental, this leads to unauthorized modifications in the application or the system. The next threat I will cover insecure APIs and interfaces. The APIs are the most exposed parts of the system due to the as they are usually open to public. And for the cloud native environments, there are some unique security patterns unique patterns and threats due to the dynamic scaling, the automation, and distributed systems. Let's see what is the context for discovering this type of threats. So as I mentioned earlier, the APIs are expected to be the most vulnerable part of the system. The API being down, or it could lead to data leakage, or even some of the critical parts being exposed. And one of the mitigation strategy would be applying Threat Modeler. This needs to be applied as early as possible in the software development lifecycle. I will provide an example of how Threat Modeler would have helped having a better informed decision. Another strategy is conducting security reviews, security-oriented code reviews. Security scans needs to be integrated in the pipeline, like check marks, burp, and other SCA tools. The pen test should be run regularly. For example, in our case, the pen test is also mandatory to be sent to the banks, the whole report having critical highs and mediums resolved within a certain SLA. Like the medium ones needs to be resolved in 90 days, highs and criticals in 30 days, and the whole report needs to be cleaned. This exercise is run annually. And I'd like to dive in an example where Threat Modeler was useful. In a previous project, we had a business requirement to implement credit card payments using, and we chose Chase as a vendor. Though Chase is a trusted provider and also has a secure API, the credit card data still pass through our backend systems, and before being sent to Chase, this was a security risk that was not fully, the PCI audits were not fully accounted for, and it would have made the PCI audit much more complex. To explain how the credit card data is stored and handled through the system. A data flow diagram would have shown this risk. And at the time, this seemed like the fastest solution, but we didn't fully account for the fully compliant PCI audited solution. And then I led the reevaluation of the architecture, and one of the options was to integrate an iframe. This provided us with a more simple solution to bypass the credit card data directly to Chase, and made the PCI audit more simple. So the key lesson learned here was applying a threat modeler early in the design phase. It would have helped us made a more informed decision in the beginning and avoid the rework. Then I'd like to cover some common vulnerabilities. Authentication abuse. This is especially relevant in web applications. This type of abuse targets flaws in how authentication is implemented. This is different from the bypass. And imagine a web app where the user wants to reset their password and gets the password link on the email. If the token doesn't have an expiration period, the token could be reused, and this way an attacker could exploit this scenario. And this is one example of a flaw in the authentication system, but it's not a bypass. Let's see what would be the mitigation strategies for authentication abuse. As expecting the multi-factor authentication, even the credentials would be leaked. There is an extra layer of security in order to authenticate. The strong password policies, like the complexity of the password history check and password expiration, would be some policies, and regular pen testing, as by simulating a real-world attack. It could uncover vulnerabilities that might have been unnoticed before. Specifically in Azure, Azure DB, Azure Redis Cache, Azure API, or web apps, all of them should have communication between Azure and the web app and the app SSL encrypted. For the web app, we need to be added a certificate for each custom domain. This is what we done for each store. And for the database, the encrypt SSL needs to be true to enforce SSL in the usage in the connection string. The next common vulnerability insider threats, as mentioned earlier, this can originate from contractors, partners, employees. The motivations could come from would include data theft, revenge, or sabotage. And cloud environments are especially vulnerable to this type of attacks due to the remote access. In order to mitigate this threat, the organizations need to control encryption. Both the data in transit and the rest needs to be encrypted. And manage the access rights effectively. It needs to be used the principle of the least privilege principle. The access should be only as much as necessary for each type of role. For example, we have a group that has access only to their corresponding environment. The developers have access to development. The testing environment is owned by QA. Then the product team owns the UAT, and production by certain groups, and even those are segregated. Like AppOps has access to some of the Azure resources. The database is owned by the cloud database team. Another strategy would be effective logging and monitoring. It needs to be monitored, all the authentication logs associated with a timestamp and the user that performed a certain action. Other strategies would include using a change management system. All our production and even UAT changes are done through ServiceNow. We have a rigorous approval system. There are layers of approvers besides the first layer that reviews the change and change advisory board that reviews the high impact changes. Then the technical owners approve the change according to depending on the tasks that are part of the change, so as to validate the actions that the modifications that could be done during the change. Other strategies would be training the employees. We have an annual security training, not only for developers, but also an extended basic security training, and a clear incident response plan. This plan should include containment, investigation, and recovery, and should be owned by CISO and having a shared responsibility with risk management and leadership teams. For this type of threats, specifically for Azure, as mentioned earlier, is the same authentication strategy. It needs to be used. There needs to be used standard protocols like OAuth or OpenID Connect, JWT validation. We use the JWT validation and mutual TLS to validate to secure the communication between client and the web API. Another recommendation is to reference the secrets from the key vault. For example, we migrated most of the secrets that were even stored in the pipeline securely, and were not accessible by developers, not even by DevOps after they were added. But it's best to be in the key vault. Together with, we also have encryption keys stored in the key vault. Another recommendation would be to restrict the IPs for the apps. They are whitelisted, some of the IPs, especially in the Azure API and Azure Web App. And for the Azure DB, some of the auditing retention policies restricting access by using firewall rules and configure alerts to send to the appropriate teams. Next, in general, let's cover a few key security practices for protecting the web apps. When designing API authentication, it's best to have a max retry limit on failed attempts. We implemented this a few years ago to prevent brute force attacks. However, it was found in one of the pen tests that in a certain area, in the discount area, this wasn't enough, and we added an additional security for the UI reCAPTCHA and the limit for submitting discounts subsequently. That could have made the API being overloaded. It would have led to other concerns. Additionally, rate control mechanisms should be set, so limit to consecutive failed attempts and strong authentication using standard protocols. For GWT in particular, it needs to be, it's best to have shortened token expiration time. So we have fields where the expiration time can be configured even through the API for encryption. Avoid storing sensitive data in the GWT payload, and the payload should be as small as possible. Though we kept in the order interface most of only the fields that were mandatory. Other design considerations, for example, for large data processing, use workers or queues in order to fasten the response times. We used async await not to block the interface or improve the perceived performance, especially for those database queries or API requests that would take a longer time. We added caching using Redis cache, and payload was mostly redesigned for the past couple of months to have only the necessary fields. And this improved the performance as well. Other best practices regarding API communication, the API gateway would be useful to route all API calls. We used APIM, and in another project, IBM Data Power. As mentioned earlier, restricting the access to APIs. Regarding the process and governance for API security, it's best to have a data classification exercise. We perform this exercise annually. The check SAS, DAST, and SCA are integrated into the pipeline. I will show how this was integrated. It's best to have API testing collections to that would validate also the security. We have them stored in Postman, and the API definitions, the Swagger specs should be also updated. Here it is a screenshot with the check marks integrated into the pipeline. This would allow developers to have an early feedback of the vulnerabilities that were introduced. The ACA means scanning of the third-party libs. We use Arnica for this. There were actually resolved a lot of vulnerabilities even before they were reported while upgrading the libraries. And here we can see that there are only lows in these repos across the board. Specifically for API coding, there are some best practices like utilizing unique identifiers, encrypting the data as mentioned earlier. Next, I'd like to cover the APIM and Azure Key Vault. How many of you are using APIM? Cool. And Key Vault, Azure Key Vault? More people. That's interesting. So you don't manage the API in APIM. The APIM provides other policies like rate limits, CORS and CRS and JWT validation. First, this was the first approach, and then we actually deployed the web app, the Azure API as a web app. And the Key Vault centralizes all the keys and keys, secrets, and certificates. Next, I would like to walk you through some of the steps we have done for setting up APIM. After the creation of the instance and the API app, the two are linked together. The next screenshot shows that how the inbound processing policy was set up in order to have an authentication using a certificate. And this could have also implemented in the code, but APIM provides this setup to avoid custom implementation. And this is the full configuration of the inbound processing policy. Then there are some screenshots for managing the certificates in APIM. The OAuth and JWT can be configured here under after defining the API under security tab. And also the TLS protocols and cipher suits can be configured to, it needs to be the latest TLS version. This is would be the recommendation, and avoid weak ciphers. Then the Key Vault, as mentioned earlier, contains the keys, secrets, and certificates, and it has a feature for automatic key rotation. That's why it would be preferred. Here are the methods that could be configured for key, secrets, and certificates. And next, I would like to talk about threat modeling framework. The outcome would be to identify potential attack vectors to safeguard your API. For example, we use a structured framework for threat modeling, which we complete annually for each product. It starts with identifying the critical assets, the entry and exit points of the application, then the data stores, the trust levels, and each role, and lastly, identifying the threats and the mitigation. So first, we identify the trust and role levels. We outlined here the roles that are available for this product. The app ops are the system administrator, for example, and have the highest level of trust and access. And there are application administrator, operations team, and lastly, for the portal website, there are the customers that have access only to the personal data. And we identified those assets the customer data, the credit card information, and the customer transaction data, the key assets that an attacker would be interested in. And this needs to be kept secure. The next step was identifying the data stores. The main DB keeps information about most of the data related to business critical operations. Then there are the logs, the configuration file on the app server, and the logs that are used for incident resolution as well. The next part would be identifying some of the threat scenarios. For this particular product, CCRF in the web UI is one common threat, and I will show what would be the mitigation for it, especially in the payments methods. CCRF would mean that an attacker would exploit a scenario where and it would gain unauthorized access to a method that should not be revealed. So the attacker tricks the user, and one of the mitigation would be setting up an anti-CCRF token. It was also part of a recommendation from the burp scan. And lastly, I want to show the authentication data flow using a two-way SSL. Here, the third-party app is authenticating using an encrypted payload. Our Azure API decrypts the payload, so it has methods especially for those in that area, and interacts with the key vault to verify the keys. After the request is, the response is valid, user is authenticated, and the web app executes logic and interacts with the SQL database. Then the third-party app is authenticated and able to request various operations. Lastly, this is the threat modeler diagram that I created in the threat modeler tool, that we're able to visualize the Azure resources that were used. The Azure API that I mentioned earlier, the web app, there is a Redis cache for caching, and also an on-prem part for some of the API methods. And in summary, I covered some of the common vulnerabilities, the Azure Tools APIM and key vaults, and the threat modeler structured framework that would help identify the risks early in the SDLC. That's all.
Cool. Thank you, Adelina.